This video will discuss lot sizing in material requirements planning models. And what's shown here is the material requirements plan for item E in the problem that's in the MRP tutorial. Item E has a lead time of 3 weeks. The parent of item E is B in this problem. And the gross requirements for item E are linked to the planned order releases for B, which is the parent. That's not shown here in this template, but the gross requirements are simply repeated from the solution to the previous problem here. But in the previous problem where we're planning all the items, gross requirements are always linked to the planned order releases for the parent, and they consider how many of the item are required for each of the parent. Okay, so for item E, there was also a scheduled receipt in that example of 450 units in week 1, and there was a projected on-hand balance of 100. All of the other formulas in the template are set up as in previous examples. Okay, recall we've got the projected on-hand inventory formula. It's the previous projected on-hand plus receipts of inventory, planned order receipts and scheduled receipts, minus gross requirements, which are uses of inventory. Right now it looks strange down here with the negative numbers, but that's because I haven't filled in any of the planned order receipts. Net requirements, of course, are the maximum of 0 or the gross requirement minus projected on hand. So we're going to consider, previously we've considered a lot for lot sizing rule. And what that means is that the planned order receipts are simply equal to the net requirements for each item. And so we would just enter the planned order receipt, and copy that over. Okay, so it almost makes it, in this sense, lot for lot, it almost makes the net requirement line and the planned order receipt line seem redundant. All we're ever doing is making sure that these two things equal. It's a just-in-time system. Now, what we need to consider is there's a possibility we could do some other things to reduce our cost in terms of the order sizes that we're doing. And to do that, we need to use some principles that we've seen before in inventory management. And those are the fixed ordering cost and the holding cost. So in this example, we're going to include a fixed ordering cost of $100. We're assuming that each time we place an order with the supplier, there's a cost of $100 to handle that order. That's whether the order is for 10 units or 100 units. Always $100 to handle the order. We're going to assume a fixed, or not a fixed, but a holding cost in this example of 25 cents per unit per week. So it's a per unit per week holding cost in this case. We know that order size in inventory management is a balance between fixed ordering cost and holding cost. And it's no different in this material requirements plan model. Okay, so if we consider that those are our two costs, we're going to calculate our setup cost and our holding cost, and the sum of those two things will be the total cost. Setup cost and ordering costs in this case are really used synonymously, and that's because we might either be ordering these items from an outside supplier or we might produce them ourselves. All right, so here we have the lot for lot ordering rule. And we're going to make one adjustment or addition to this template to consider lot sizing rules. And that is that I'm going to extend the projected on-hand inventory formula one more week. Because the week 13 projected on hand is really the beginning balance, which is the same thing as the ending balance for week 12. So when we consider holding costs, we want to consider how much we're ending up with. All right, so let's calculate the setup cost or fixed ordering cost for this model. Well, we've got 1, 2, 3, 4, 5, 6, 7 orders that we're receiving. And so we can count those. I'm going to use this function, COUNTIF, highlight the planned order receipts, and then enter a criteria. And the criteria is that a planned order receipt is greater than 0. And interestingly, you have to put this mathematical criteria in these quotation marks. And so that's going to count up to 7 because there are 7 orders where the planned order receipt is not 0. And then we would just multiply that times the fixed ordering cost. I use this A as the fixed ordering cost because that's the term or the notation we used in inventory models. So this should be a $700 cost as a fixed ordering cost. Okay, so now we need to consider the holding cost. All right, so what we're going to do, it's a holding cost per unit per week. So we need to count the total number of units that are in inventory at any given time for this item. So I'm just going to sum up all the projected on-hand balances from week 2 to week 13. And the reason I went from week 2 to week 13 is because this beginning balance for week 1, there's really nothing we can do about that as a result of changing order policies for the current time horizon. So we're going to ignore that. We can change what's left at the end of week 12 or the beginning of 13. So we multiply that sum by the per unit holding cost per week. And then we would add those two together. Okay, 937.5. So that's our total inventory related cost for a lot model. Now we're going to consider two alternatives. I'm going to copy these costs down here. And we're going to evaluate setup, holding, and total. The next ordering rule is called a periodic order quantity 2-week rule. And what happens is we just start here at week 1, and with a 2-week rule, we look for the first instance where we have a positive net requirement. So we don't have any positive net requirements for the first 4 weeks until we get to week 5. When we have a positive net requirement, it's a 2-week order policy. So what we would do is order the current net requirement, that's 1 week, plus the next gross requirement, that makes it 2 weeks. And that would be our planned order receipt. And you notice what happens, we end up carrying 100 units over to week 6 so that we don't have a net requirement there. So that would be 0. We get to week 7, we have a positive gross net requirement. So we order 1 net requirement plus an additional gross requirement. That's 2 weeks. And that satisfies our needs for week 7 and week 8. In week 9, we have a net requirement of 125. We're using a 2-week rule. So we order the current net requirement plus one additional gross requirement. And then week 11 is the last one. It would be a 2-week rule. We don't have any gross requirements in week 12, but we'll go ahead and build the formula out. And so those are our planned order releases in this model. I've got the lead time set up. It's a 3-week lead time, so you can see that the planned order releases are 3 weeks ahead of the planned order receipts. Now, what are the costs for this model? Well, we'll count the setups. When are the planned order releases greater than or equal to 0? Specifically, count them if they are. There should be 4 of them that are greater than 0. So we should pay the fixed ordering cost 4 times. We need to carry down our week 13 inventory balance. And then we see the number of units that we've held in inventory. Again, only week 2 to week 13. We can't do anything about the beginning of week 1 balance with this new plan. Times our unit holding cost. And so our total costs are $712 for the 2-week POQ model versus $937 for the lot model. So we may want to consider 2-week POQ over lot for lot if we're willing to hold inventory. And there's other managerial considerations, but certainly on the basis of these costs, it looks like it could be beneficial. All right, so let's try 3-week POQ. I'll put my cost in the template. All right, so we wait till we find a positive net requirement. This is a 3-week model. So we order the current net requirement plus the next 2 gross requirements. That's the 3-week model. By the time we get to week 8, we come again to an additional positive net requirement. So we order the current net requirement plus the next 2 gross requirements. A 3-week model. Week 11, we don't have 3 weeks, but we'll go ahead and we'll extend it to the 2 weeks that we do have and plan that order. Keep in mind that for these out weeks, we're going to be rolling over this plan probably every month. So this order likely could get adjusted by the time it actually happens. So the setup cost, and by the way, we can see that there's going to be 3 setups or 3 orders. But this formula is just a way to build in something that you could reuse fairly easily. We're going to pay the $100 3 times. What about holding cost? Need to extend the inventory formula to week 13. Sum the projected on-hand balances and multiply that times the unit holding cost. And that'll give us our holding cost. And so that's 681.25. So strictly based on cost, it looks like we would want to choose the 3-week periodic order quantity over the other 2 possibilities.